Hello, everyone. One of the things that you should know, just as an educated person, is one of the things we learn in grade school, of course. One of those things that we should know is the fractional equivalence of certain decimals and percentages. And I actually have a fun way that I do them. I say fun; it's fun for me, but most normal people wouldn't say so. But anyways, I'm going to try to teach you that way so you can learn various fractions, their decimal equivalents, as well as their percent equivalents. So all it really takes in this case is your ability to think about money. So I'm going to start off with the idea of a dollar being 100 cents, and then what a half a dollar would be, and so on and so forth. And I'll keep going by halves because division by half is our multiplying by one half, our division by one half, our division by two is a pretty easy thing to do. Basically, dividing by two, if the number is even, you just cut it in half. If the number is not even, you try to get as close to even as possible, and then divide the last one that's left by half. So let's give that a try. Switch over to my document cam. So really what we need to know is I've drawn the fraction 1/2 there, but I want to start off with something up here. I just want you to know, for instance, that $1 written like that is the same thing as $1.00, which is also the same thing as 50 cents, which is also the same thing as $0.50. So just keep that in mind. That'll help you. So for instance, right now, I'm going to try to tackle the fraction 1/2. Well, I know half of a dollar is in fact 50 cents, and 50 cents is literally listed as 0.50. So I know already that 1/2 is 0.50, and actually it goes zero forever. And of course, to make a decimal into percent, you just move the decimal two places to the right, because percent means divide by 100. Per in mathematics is normally just means divide by, and then cent, as you know, there's 100 cents in a dollar, should suggest 100. So we're just going to divide by 100, which in fact makes it 50%. So that's easy peasy. Well, let's jump up here and say, what about 1/2? Well, 1/2 of a half is basically 1/2 of a half. Of means multiply, means 1/2 times 1/2. Well, when you multiply fractions, you just multiply their numerators to get a new numerator. You multiply their denominators to get a new denominator. And if there's any cancellations, since all this is multiplication and division, if there's like a matching 2 and 2 up here, or an 8 and an 8, or a 7 and a 7, you cancel those out. But in this case, I didn't have them because these are all prime. So half of a half is 1/4. So if I go up here about half of the way, I can say 1/4. Well, 1/4 is half of a half. So what's half of a half dollar? I think you know that half of a half dollar is, of course, 25 cents. So you can immediately write this as 0.25. And again, we can make that into a percent by moving the decimal two places to the right. So that's 25%. So I can go half again. What's half of 1/4? Well, 1/2 of 1/4 would be 1/8. Again, I didn't have anything on the top and bottom that matched, so they couldn't be canceled out. So I get to 1/8. So I go up here and write 1/8, even though I wrote 1/2 for some reason, but I'm going to write 1/8. And with 1/8, I'm going to say, okay, well, I got 25 cents. Let's take away that 1, that 5 cents on the end, and change that to 24. I know that half of 24 would be 12 cents. But now I need to take a half of a cent. And of course, you remember that a half is 0.5. So if I did 0.5 cent, that would be a 5 right here after the 0, which would be the same thing as a 5 right here after this 0, which would be the third place down. So I'm going to put a 5 right here. So now I know that 1/8 is 0.125, which is also 12.5%. Now here's the last one I'm going to do. I'm going to say, what is a half of an eighth? Well, a half of 1/8, of course, is 1/16. And 1/16 is kind of nice. 1/16, I can say, okay, well, 1/16 is half of 12.5 cents. So 12 is actually even, so that's pretty good. I can say 0.06 because that's 6 cents, which is half of the 12. But now I need a half of a cent, but we already learned that a half of a half was a quarter. So a quarter of a cent would be 0.25 right here after this zero, which is the same thing as 25 in the third and fourth spot. So I'll say 1, 2, here's the third, and here's the fourth spot. So a 16th is in fact 6.25%. Okay, so from that little knowledge about dollars and stuff like that, we now have the fraction, the decimal and percentage equivalents for these fractions: 1/2, 1/4, 1/8, so on and so forth. Obviously, if you wanted to do 2/16, I think you see that 2/16 is the same thing as 2 times 1 over 2 times 8. And since this is all multiplication and division, these 2's can cancel out, and I get that it's 1/8. So I've already handled that case. So there's nothing to do with 2/16. But what about 3/16? Well, 3/16, that's just going to be 3 of these. Well, 3 times 6 is 18. So I know that's going to be 0.18. And then 3 times 25 is 75. So I'll put 75 there, just like 3 times 3/4 is 75 cents. So I know that 3/16 is 0.1875, which would be 18.75%. So that's a kind of nice, neat way. What about 4/16? Well, 4/16 is the same thing as 2 times 2 times 1 over 2 times 2, which is 4, times 2 times 2, which is another 4, times 1. So I think you can see that this 2 and this 2 will cancel out, this 2 and this 2 will cancel out, and I'm left with just 1 over 2 times 2 times 2, which is 1/8. But I already handled, which is, cancel something out there. 4/16 is 2 times 2, 16 is 4 times 4. Oh, this is supposed to be a 1, no wonder. Duh. So that's just 1/4. Sorry about that mistake there, everybody. I couldn't read my own handwriting. It was 2 times 2 times 1 over 2 times 2 times 2 times 2 times 1, and I read that as a 2, so that's what screwed me up. So it's 2 times 2 in the bottom, that's just 1/4. So I've already got that one covered. So what about, that was 4/16. What about 5/16? Well, 5/16 is just 5 times 1/16. So 5 times 6, of course, is 30, so that's 0.30. But then 5 times 25, that's 5/4, that's $1.25. So that's actually going to put a 125 here. So in fact, it's not that, it's 0.3125, or 31.25%. 6/16, that's the same thing as 2 times 3 over 2 times 8. The 2's cancel out, that's 3/8. Well, 3/8 is 3 times this. Well, 3 times 12 is 36, and 3 times 0.5 is 1.5. So this should be 37.5. So 6/16 turned out to be 3/8, which is 0.375. Excuse me. Yeah, 0.375, which is 37.5%. Okay. Now, if I went up to say 7/16, now 7/16 is just 7 times 1/16. 7 times 6, of course, is 42. And then 7 times 25 would be 7/4. So 4 of those make $1. The other 3 make 75 cents. So I'm going to do 7 times 6, which is 42, and then add $1, it'd be 43.75. which equals 43.75%. And of course, this is 7/16, which is only 1/16 away from 8/16, which I think you can tell would be 1/2. So I've now gotten all these wonderful fractions, 1/16, 1/8, 3/16, 1/4, 5/16, 3/8, 7/16, 1/2. Now what if I go up here and go to, let's say, 3/4? Another way of saying this you've probably all learned before, 3/4 is the same thing as 3/4. And of course, a quarter is 25 cents. So I think you automatically know this is 0.75, which is 75%. Easy peasy, right? But what about some other things? What if I go beyond 8/16? What if I go to 9/16? Well, if I went to 9/16, then I know that's just 9 times 0.0625. 9 times 0.0625. If I do 9 times 6, I know that 9 times 6 is just 54. So I got 54 there. And then if I do 9 times 25, that's 9 quarters. 9 quarters is basically $2.25. So 54 becomes 56.25. So this is 0.5625, which is equal to 56.25%. Now that was a really ugly way, and I had to do a buttload of math, right? But look at this. I know that 9/16 is just 1/16 bigger than a half. So why didn't I just add 0.0625 to 0.5? And lo and behold, I get 0.5 and then 625, which is exactly what I got. So that's a much easier way of thinking about it. Same thing you could have done here. If I did 0.0625 plus 0.0625, you'd immediately get 12.5. And then if I added 0.0625 to 12.5, you see this 6 would line up with this 2, that'd be making 18, and this 2 would line up with this 5, that'd be 7, so 1875, which is exactly what we got for 3/16. Similarly, 1/4 was the same thing as 4/16, so 5/16 is just 0.0625 above that. So if I added 6.25 cents to 25 cents, I'd get 31.25 cents, which is, lo and behold, 31.25. And similarly, I could add another 0.0625 to get 3/8, so on and so forth. Now, if I go up a little further, 9/16 plus another 16 would actually be 10/16, and that turns out to be 5/8. But 5/8, notice, is just 1/8 bigger than 4/8. 4/8 is a half, so that's 0.5, and 1/8 is 0.125, so that's 0.625, which equals 62.5%. Now, if I want to go to 11/16, which would be, remember, this is 10/16, so 11/16 would just be 1/16 bigger. So if I want to go to 11/16, then I just add a 16th of that. And a 16th is 0.0625. So if I put 0.0625 to this, I think you see what happens. 0.625 plus 0.0625 is going to be a 5 over here. And then 625 and then 0.062, so that'd be a 7. And 625.06, that'll be an 8. And then 6. So it's 0.6875, which is 68.75%. Okay. Of course, we could also do that with 11 times 16, and that should get it for you as well. Let's check our math, just because I was trying to add that in my head, and adding in your head is bad enough, but adding in your head while being recorded is kind of scary. So let's just make sure I did my math right. 0.625, which is 5/8, added to 0.0625. I can add a 0 on here. That clearly makes a 5 here. That makes a 7 here. That makes an 8 here and a 6 there and a 0 point. So yes, I was correct. 11 sixteenths is 0.0625. 12 sixteenths, I think you can tell, could be 3 times 4 times 1 over 4 times 4 times 1. Drop that, I get 3/4. So I've already got that with 12 sixteenths because 12 sixteenths is 3/4. Now, if I go to 13 sixteenths, which is the next one up, that's just 0.0625 added to that. So if I add 0.0625 to 0.75, 0.0625, the 6 will add with this 5 to make 11. So it'll make this, instead of 0.7, it'll make it 0.8. And then this 0.06 added to this made 11. That 1 caused this, but there's a 1 here as well. And then this would be 1 here. So 13 16 should be 0.811. Well, is that correct? I don't remember that fraction. In fact, I usually don't remember my sixteenths. I do it like this really quickly. So let's double check our math. 0.75 plus 0.06. Oh, 25. No wonder. I'm glad I checked that because I was adding 625, but I think I forgot this. So that's clearly going to be wrong there. That's 25. See? Okay, so when I add these, I add a 0 and a 0. 0 plus 5 is 5. 0 plus 2 is 2. 5 plus 6 is 11. 1 plus 7 is 8. So it's 0.8125. So I was sort of correct. I was correct when I corrected myself. So that ends up giving you 81.25%. 14 sixteenths, I think you can tell, is going to be what? 2 times 7 over 2 times 8. That's just 7/8. Well, 7/8 is just 1/8 plus 3/4, right? So 7/8 is just 1/8 plus 6/8. But 6/8, of course, is 3/4. So I'm just going to add 0.125 to this, and you see that's 0.875. So putting 125 there, that's going to be 87.5 equals 0.875. The 8s I do memorize, or I do have committed to memory. The 16ths I don't, but I quickly know them. So this is 87.5%. Okay. Now next we can go from 14 sixteenths, which we learned with 7/8, to 15 sixteenths. And of course 15 sixteenths is only 1/16 larger than this. So again, this is 0.0625 with all that. So the 6 with a 7 ultimately gives me 13. So that's going to make that 9. 6 with a 7 is going to make 13, but it's 0.0625. So this 5 is going to be a 7 and then a 5 there. So that's 93.75%. So let's check our math just to make sure. 0.875 plus 0.0625. By the way, the 1/16 I always memorize. That's just stuck in my brain anyways. So 0 plus 5 is 5. 5 plus 2 is 7. 7 plus 6 is 13. 8 plus 1 is 9. So it's 0.9375. So that's exactly correct. And 16 sixteenths, of course, is 1, which equals 1.00, which equals 100%. So that's a good chunk of fractions, more than people normally expect people to know. So for instance, we got that 1/16 is 0.625. 2/16 is 1/8, which is double that, so it's 12.5 cents. 3/16 is 0.1875, or 18.75. 4/16 is 1/4, so that's also 2/8, which is 25, like 25 cents, so it's 0.25 or 25%. 5/16 is just adding another 0.0625 to the last one, and I got 0.3125, which became 31.25%. Then 6/16 is 3/8, and that gave me 37.5%. Then 7/16 is 40 0.4375, which is 43.75%. 1/2 is 0.5 or 50%. 9/16 is 0.5625, which is 56.25%. 5/8 is 0.625, which is 62.5%. 11/16 is 0.06875 or 68.75%. 3/4 is 0.75%. 13/16 is 0.8125 or 81.25%. 7/8 is 0.875 or 87.5%. 15/16 is 93.75%. And of course, 16/16 is 1/1, which is 1, which is 1, which is 100%. Okay, that got you most of your fractions. Now there's a couple others that jump into play. One is 1/5. So let's start off with that, thinking about 1/5. So 1/5, let's think about $1 again. So $1, I happen to know what I want to break this up into, so I'm just going to break it up into dimes. That's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's actually 10 dimes. And 1/5 would be 1/5 as many dimes. So if I divide 10 dimes by 5, 10 divided by 5 is just 2. So in fact, 2 dimes, maybe say these two, make up 1/5. So that automatically tells me it's 0.20 or 20%. So we start off with 1/5, and we've got 0.20, which is 20%. 2/5 is, of course, going to be twice as big as 1/5, so that's 40%, or also 0.40. 3/5 is 3 times as big as 1/5, so that's basically 6 dimes, which is $0.60, which is 60%. And 4/5, which is 8 dimes, is 0.80, which is 80%. So that's another fraction that we often use. Another one that we do, and this one's a little more complicated, but I think you can figure out what's going on with this one. This one is 1/3. And 1/3, really to determine what a fraction equivalent to a certain, or what decimal a certain fraction is equivalent to, you just treat it as a division problem. So you're dividing 3 into 1. So let me show you what happens with that. I'll write it over here. I'm going to put 3 into 1.0000. And of course, we do long division this way. So 3 does not go into 1, so I'll put a 0 up top there. But 3 does go into the 10. It goes into there 3 times. 3 times 3 is 9. 10 minus 9 is 1. Bring down the 0, I get 10. 3 goes into 10 3 times. 3 times 3 is 9. I do this, I subtract 9, I get 1 left over. I think you can see where we're going. We're going 3, 3, 3. So in fact, 1/3 is equal to 0.33 going on forever. But we can do better than that. For instance, I can say 0.3333 and say that goes on forever. Then I could realize this is about 33%. But what is this 0.0033? Well, there's actually a trick to doing this. You can, for instance, multiply this by 100. Let's call this x. And let's multiply this by 100. So I say that 100x is equal to 33.33. So remember, multiplying by 100 just means to move the decimal 2 places to the right. And now if I take this x, which is 0.3333, and I subtract them, I get 100x minus x is 99x. And 33.3333 minus 0.3333 is just 33. So lo and behold, I get x is just 33 over 99, which is 3 times 11 over 9 times 11. So that's just 3 times 11 over 9 times 11. The 11s cancel out, but also 3 goes into 9 3 times because this is 3 times 3. So this just becomes 1/3. So what I see is that last 0.33 that I had here by moving it 2 places to the left, that's the 0.33%. But what's left over is 1/3. So I can do 33 and 1/3. And then I therefore call it, moving the decimal 2 places to the right, that's 33 and 1/3%. Similarly, the other fraction of this type is 2/3, which I think you've all done this part before. When you divide that, instead of 2 here, you've got 3 going into 20. Obviously, 3 doesn't go into 2, I get a 0, but 3 does go into 20. How many times? It goes 6 times, because 6 times 3 is 18, so it'd be 6. 2 left over, bring down to 1, that's 20 again, so it's going to be 6, 6, 6, 6. So lo and behold, this becomes 0.6666, which I could write this too, by the way, and most people normally do when it's in decimal form. 3 forever. I could write this as 66 2/3%. Okay, so that's your thirds. So now I've got fifths, I got sixteenths, I got eighths, I got quarters, I got fifths and thirds. The last two, or the last few, I should say, is 1/6. So what is 1/6? Of course, 2/6 is just 1/3, so that doesn't help. 3/6 is 1/2. 4/6 is 2/3. 5/6 is something that's relevant though. So we're going to do 1/6 and 5/6. So if I take 6 and divide it into 1.0000, I see that 6 does not go into 1. It does go into 10 one time. 1 times 6 is 6. 10 minus 6 is 4. Bring down to 0, I get 40. 6 goes into 40 6 times, and that's 36, which gives me a 4 left over. I bring down the next 0. That gives me 40. I'm starting to see a pattern already. So 1/6 is in fact 0.1666 forever. But just like before, when we found 0.666666 was 66 2/3, this is going to be 16 2/3%. And then finally, 5/6 is going to be a similar scenario. So if I try to divide 6 into 5.0000, 6 does not go into 5, so I'll put a 0 there, but 6 does go into 50. 6 goes into 50. Anybody know how many times? Okay, so 6 times 6 is 36. 6 times 7 is 42. 6 times 8 is 40. Ooh, lost my train of thought there. 6 times 8 is 48. So that's the one, right? So 6 times 8 should give me 48. 8 times 6 is 48. Sorry about that, lost my train of thought. 50 minus 8, 48 is 2. Bring down to 0, I get 20. 6 goes into 20 3 times. 3 times 6 is 18. Minus 2 gives me 20. That gives me 2, but I bring down to 0. That gives me 20. That's a 3, 3 again, and I think you can see it's going to continue. So 5/6 is in fact 0.8333, which I think you can tell is 83 1/3%. So those are the fractions that everybody should know. They're 1/16, 1/8, 3/16, 1/4, 5/16, 3/8, 1/2, 9/16, 5/8, 11/16, 3/4, 13/16, 7/8, 15/16, 1/5, 2/5, 3/5, 4/5, 1/3, 2/3, 1/6, 5/6. These are sort of the ones that any all the math books I've ever worked with sort of expect you to know off the top of your head. The last two being the most obscure, 1/6 and 5/6. Well, actually, that one and the whole 1/16 stuff isn't that helpful, but I know a lot of people that work in the machinist field have to memorize the 16th. So I thought this might be helpful for machinists as well. So that's our big results. So I hope this helped someone. Everyone have a good day.